Now, as we came to the conclusion that our source is charge, so we will discuss charge first in order to proceed further in the electrodynamics. So let's start with the electric charge. We represent this with symbol Q. Now we know about the charge that it is an intrinsic property of the material. So when things are intrinsic in nature, then we cannot define them. The only thing we can discuss about them is their properties. So the very first, that charge is occurring in two varieties. Like it can be two varieties. It can be a plus charge or a minus charge. The magnitude of both are the same, but the charge can be either positive or negative, such that when the charges are like charges, for example, plus plus or minus minus, they will repel each other, while the opposite charges will attract each other. So this is the property of the charges. And now what if, for example, we say that there are not two varieties of charges, maybe there will be more variety of charges, then to that one I will say that one of the that subject is dealing with more properties, like the one which is chromodynamics. Now chromodynamics, a field which is inspired from electrodynamics, it deals with charge, it deals with mass. It is having another thing which is related to charge, but it is not charge. It is called color charge. And then it deals with the spin of the particle as well. So chromodynamics, we are not discussing the chromodynamics, but we will only limit ourselves to the classical electrodynamics or the basic electrodynamics. So charge comes in two varieties, plus and minus, and they are exactly equal in magnitude. So if I consider a bulk material, so in bulk material, if it's a neutral material, then the plus and minus are exactly cancelling each other, and the cancellation or their magnitudes are exactly equal. The cancellation is even up to maximum, you can say numbers like this. If even 10 to the power 10 magnitude, their magnitudes are not equal, then even a potato will explode if the neutrality is not like this. So it is like when the plus magnitude and the minus magnitude. In the bulk material, it's a neutral material and they will cancel each other. This cancellation is up to 10 power 10 exactly accurate. Even if it is not accurate, then there will be an explosion in a bulk material like in a potato. It will explode if this neutrality is not occurring there. So they are perfectly cancelling each other with a precision. Now another property of this charge we will discuss is the conservation of charge. The conservation of charge. The charge is conserved. Charge can neither be created nor it can be destroyed. So if we are having a neutral body, Then a neutral body, we say that for a neutral body the charge is zero. It means the plus charge and the minus charge are exactly cancelling each other, and that's why we are having the conservation of charge. If for example I want to have a positive charge, then how I will be able to get this positive charge? I will have to take this charge from a neutral body, and then that body will become a negative charge if I take positive charge out of it. If for example we are having a neutral body and I take one electron from it, so that one electron is having a negative charge equal to some magnitude which I am discussing in a moment. But the rest of the charge, the rest of the material will then have exactly the same amount of positive charge, and you combine globally we are having the same amount of charge. It is not it is we haven't created a charge. If we are having a plus and minus equal magnitude of charges, we combine it and it become neutral. So it seems that we have destroyed a charge, but in reality the charge is there. If we have made it neutral but the charge is there, we can at any instant we can again get the charges back from it. So this is called the global conservation of charge. So charge will always remain conserved. This universe is having a fixed amount of charge. We cannot increase or decrease that charge. And we are having a formulation for the conservation of charge, which we call the continuity equation, which is giving us the conservation of charge, and this is the divergence of the current density is equal to curly rho over curly t with a minus sign. So this is current density will diverge, will have non-zero divergence when there will be a change in the charge density in time. So if for example the electric charge density rho is constant in time, then there will be no divergence of current. Divergence of J will be equal to zero. There will be no accumulation of charges. Like if we are having a surface and the surface is completely smooth and water is flowing on this surface, we will never come to know that water is flowing on this surface because water is transparent. So there will be no bumps and humps in this flow because the surface is very smooth. This is like the rho is not changing with time, like the surface, the particles of the surface are not changing during this flow, during this per unit time. And if there will be, let's say there is a pebble on this smooth surface, so the water will just rise over there, it will create a bump there, and that bump we call the divergence of current. So this is called the conservation equation or the continuity equation of charges. So charge can neither be created nor destroyed, it will remain conserved. This universe is having a certain amount of charge which is fixed. And the things which we will discuss more is the quantization of charge. The charge is quantized. Now, what is meant by quantization of charge? Keep in mind one thing, that for electrodynamics we don't need quantization of charge, means electrodynamics is not affected by this thing. But the quantization of charge means that we know that when Millikan did his experiment, the Millikan ion drop experiment, then he found that the total charge comes out to be equal to n times E, where this n is equal to 1, 2, 3, and so on. And he not only found the value of charge, but he said that the total charge always comes as integral multiple of this number, and this number he found is equal to, we call the electronic charge. It is 1.602 10 raised to the power minus 19 coulomb. In short, we can write this 1.6 into 10 power minus 19 coulomb. This is the minimum possible charge. This is the minimum possible value of charge. Charge less than this, charge independent charge less than this is not possible in universe. So far, we have no evidence of a charge less than this amount. So the quantization means that the charge which is available in the universe, the minimum value of charge, we can't have charge less than this value. This is the minimum possible value. Charge less than this is not possible in nature. The next value of charge which is possible in nature is 3.2 10 raised to the power minus 19 coulomb. Keep in mind one thing, that this is a very, very small value, or we have selected the coulomb, the unit of charge is a very, very big unit, and that's why this fundamental value is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, 17, 18, 1602 coulomb. So coulomb is a very big unit of charge. That's why the value of charge on an electron is equal to this. Don't consider this as a negative charge. This is just a scientific notation. It's a positive value. This is another matter, that electronic charge we consider is negative, while the proton charge we consider is positive, and we consider zero charge on a neutron. So the in between value in this one is not possible. Like there is no available natural charge like 1.8 10 power minus 19. We are having in nature this available charge, this, or we are having the 4.8 10 power minus 19 coulomb of charge. And similarly, we are having 6.4, and then any multiple of this one, the integral multiple of this, we are having the charge in this form. It means that if we consider electron, then electron is not divisible. Electron is not divisible, and that's why it will transfer as a whole, and the charge on it will transfer as a whole. So this is another thing, that electron is not divisible, and that's why it's a single entity, it's a fundamental particle, and it is having this much magnitude of charge. Now if I consider proton, then inside a proton I know that proton is further divisible, and proton is also having, this is having minus E charge, so this is having plus E charge. So proton is having plus charge. Now why we are giving them plus and minus? If we place these charges in electric field, like we are having plus plate and a minus plate, and The electric field, we know that it will be from plus to minus, means the electric field will be in this direction. So if we place the electron here, then the electron will go in this direction, while if we place a proton here, it will go in this direction, and from here we give the electron is it is having a negative charge, while the proton it is having a positive charge as it is going along the direction of electric field, because we know that similar charges repel each other and unlike charges attract each other. So that's why it's a negative and it's a positive charge, electron and proton. Now what about this thing, that proton is further divisible. So in what it is divisible, that is the thing. If I consider proton, then I know that proton as well as neutron, they are the nuclear particles. We call them combined as nucleons. So they are made up of quarks. It means quarks are then the fundamental particles, and if they are made up of quarks, then the charge will also be shared among the quarks. So if the proton is having charge E and there are three, we know that there are three quarks in a proton and three quarks in a neutron, so they will share the charge. Now if I come to the proton, then I know that inside a proton we are having two up and one down quark, while the up quark is having charge plus minus 2/3, and the down quark plus minus 1/3. Now consider this one. If we are having two up quarks and one down quarks, the one down quark, then two up plus down. So it is 2/3 plus 2/3 minus 1/3. So 2/3, 2/3, 4/3 minus 1/3, it is equal to 3/3, and it is equal to 1. And if I consider neutron, the neutron is having one up and two down quarks, one up and two down quarks, and it will be equal to 2/3 minus 1/3 minus 1/3, and that's why it gives you 0, because minus 1/3 and minus 1/3 are 2/3, so 2/3 minus 2/3, and it gives you 0. So neutron is neutral particle, its net charge is equal to 0. Now if I consider the quarks, then I see that their charge is a fractional charge, like 2/3e and 1/3e. So it's a fractional charge. It means charge less than E is available in nature, but it's not true, because we don't have independent quarks. The quarks are always combined. They are coupled with each other. They can never be found separate, and that's the reason that this is the only independent smallest charge available with us. If I consider the quarks, then they are combined with such a huge energy. The energy is 125 MeV, 125 MeV per particle, but we can't see from here that how tightly they are bound. In order to separate out quarks with thermal energy, then 1 trillion Kelvin of energy is required. 1 trillion Kelvin means 10 to the power 12 Kelvin of temperature is required to separate out these quarks from each other. So we are having the fundamental available charge, the minimum possible value of charge is 1.610 raised to the power minus 19, and it is also quantized. Electron transfer is a whole, not in parts, and that's why the minimum available value of charge will be this one, then 3.2, then 4.8. Any value between these is not possible because electron cannot be splitted. So this is the basic things regarding the charge, the electric charge. And now, as we said that the positive charges are means the like charges are repelling each other and the unlike charges are attracting each other. So with how much force they are attracting or repelling each other, that we will have to study in the form of Coulomb's law. But before proceeding to Coulomb's law or electrostatics, we will first cover the first chapter of DJ Griffiths, in which we will develop some vector calculus, we will develop some tools, some mathematical theorems, which will help us in going on through rest of the electrodynamics. So the first chapter is very necessary to understand. I have come to know that some teachers even don't teach the first chapter and ignores it and jumps to the second chapter. But believe me that if you don't cover the first chapter, you will never understand rest of the electrodynamics, because these tools are extremely important. Vector calculus or vector algebra is not like the other mathematical algebra. It is a weird kind of algebra, and then we are having some fundamental theorems, some coordinate system, and all those we will cover in the first chapter. Like we are having the Dirac delta function, which is a tool required for understanding rest of the electrodynamic. So I hope you will stay tuned with me in covering the first chapter, and then we will move to the electrostatics and magnetostatics, and then electrodynamics, and then after the electrodynamics to the electromagnetic theory. And the last that we will cover will be the special theory of relativity, which is the 12th chapter of this DJ Griffiths. Thank you for being with me, and stay tuned for more lectures.